and I have a fault on this home, I cannot use the 1310 nanometers to investigate the network. So I need to use what we call live or maintenance wavelengths, which specifically 1650 should be the one that you want to use, because it's a filtered wavelength where you will not impact the network or the other customers which are connected to the network. If we are working on point-to-point or networks where we don't have service live and we will not impact other customers, then we have more flexibility. So this is as well a difference here between chip-on architecture and point-to-point architecture in terms of troubleshooting. Okay, so we will start with our fiber inspection probe, and I always like to mention this as a starting point. 80% of problems on the network comes from dirty, damaged optical connectors. Then only 10% due to macrobands and 10% due to hardware faults. So 80%, it's a lot. And I had this case and this study about the 600,000 homes in India, and they used to have 4,000 truck rolls or engineers going into the field every month just because of fiber problems. And meanwhile, 200 times were problem related with ONT and OLTs. So this is a massive impact, and this impact will impact today. The dirt will stay on the fiber, and after 5 years, as soon as the margin went down and the dirt deteriorates even more, the connection is going to be extremely difficult to troubleshoot the network. So what good looks like and what bad looks like. So Expo, we don't have the standards. We don't define the standards. So the standard for the correct fiber inspection is the IEC 61303-35 standard or the IPC 8497. And different business will have different standards. For example, manufacturing, when they supply the equipment, they would need to have a fully clean fiber. So in the field, you may allow to have some fields or particles or just small, very tiny particles that you can accept in the core, and your equipment will not fail. So if I have this fiber here, because it's scratched, then the software will have, it's a clear fail. And in terms of ITUT, the recommendation given on the G650.3 is inspect, clean if needed, and then inspect again. So also, if we inspect the fiber, we were also saving resources, and these resources are the cleaners that we use, being one-clicks or the wipes. It's all resources that we are saving if you have the tool to inspect the fiber. So if you look into the single mode fiber, and this is just a clean picture, we have the core, which is here. If you're going to go coaxial cladding, is going to be 0 to 25 microns. And then we know the core is 9 microns. And then we have the cladding. We have this adhesive layer. And then we have the contact zone. So if you're going to go, if you're going to talk about layers, it's going to be zone A, B, C, and D. This is how it's common referred on the industry. And even though today there is a require for 4 areas, some operators we have seen as well the need for an extra area where they want to make sure that if they're spending money on the network, they want to have it clean eventually as well on the external area, where if you have particles, they will move inside of the core of the fiber. So this area will keep growing. Meanwhile, we will try to improve our networks. So our equipment will give, even if we don't have the laptop or the mobile phone, which is very comfortable with our equipment, you will have the pass or fail thresholds on the unit. OTDR. So the OTDR is OTDR is one of the older instruments on the network. The principle of the working principle is you send a light from A to B. You have a reflection back. The light comes back to the A side where you have the OTDR, and by dividing the time that it took, you have your distance, because we know the speed is equal to distance divided by time. So what can we measure with the OTDR? We need to know our network to operate with the OTDR, and especially the OTDR is very useful to make sure that we are installing the right type of fiber and that we have the right, so if we have someone planning our network and he says that we have 10 kilometers at G652, we should have 3.5 dBs. So if you have 0.35 dB per kilometer, 10 kilometers will be 3.5 dB loss. So the OTDR will be the right tool to do this characterization. That's why it's a characterization tool. And we'll be able to validate that the planner and the architect of the network and the installers work on the same way. Apart from these aspects where we have the difference between 1310 and 1550, we have as well different fibers. Okay, so G652 will be, it's nowadays is the generic one. Is potentially the one that you will be installing, but I would like to call as well your attention for the G650.7. G657. So the G657 is the one that is band insensitive. So all of you working on customer houses that go to the customer that need to do corners and all those installations which are very difficult to do indoors for more diverse applications, you're going to be using the G657. And the G657 had the price much higher than the G652. With the intensification of FTTH and the demand, the G657 has been decreasing in terms of price. So I have even customers installing the G657. In terms of attenuation, you have the same values, and on the last two columns of the table, we have the dispersion values 1550, and this is important for all the characterization that occurs for networks above 10 gig. So if today you are installing FTTH for PON, GPON for 10 gig and above, you will need to start looking into dispersion and ways of compensating the dispersion if you don't do the characterization today. Okay, I don't know if someone has any question on this. We'll continue. So in terms of macro bands, and this is a very specific factor on the macro band. And if you look into a loss at 1310, where we have our GPON and EPON stream upwards at the moment, we have this minimum loss, which is here 0.1 of a dB. If you go for a 1550 nanometer wavelength, the same macro band will have a loss of 0.7 dBs or 0.699 dBs. If you're going to go for 1625 nanometers, we're going to have almost 1.3 dB on the event. So what can we see from here? We can see here that our network today works at 1310 and 1490. So it will be here below 1550. Tomorrow, if you're going to go for even 10 gig, which is just around the corner, XGS PON, we're going to go for 1570. So we will be higher here. So that means that a network which is with the low margin today may not work or operate tomorrow without the need of installing or repairing the infrastructure installed. So what in money wise, what does it mean? It means that the operators will need to invest more in order to repair a network, which they assumed it was gonna be working for the next upgrades. So on the LTDR and ILM makes it easier to spot these macrobends and these defects on the fiber. Okay, so if you're going to go, and here I'm going to use the OTDR testing through a splitter example. It's the same if you're going to do point-to-point. And the question that I always take to the seminars, to the trainings is, and even working with you guys experienced in the field, is always what parameters to choose when using with the OTDR. And if you have here, we will call F1 the first bit on the splitter, which is going to be the first leg between the OLT and splitter, and then F2, the distribution point that goes to the customer house. So if you're going to use, and the OTDR should be always used from the customer house to the CO in order to give you the real loss. And if you, what happens if you go for the CO with the OTDR? Some of you may ask that. So if you go with the OTDR with the CO, you may have an apparent loss instead of the real loss. Why is that? Because if you go from the customer house to the CO, you would have one reflection going back to your splitter leg. If you operate your OTDR or your IOLM kit from the CO, you're going to have all the legs from the splitter coming into the CO, which is going to give you an apparent loss. So that's why you need to have a more powerful equipment. And normally for the companies which are installing the operators and then the other companies which have their own fiber, we recommend other type of equipment, which is a centralized OTDR, specific for PON or point-to-point. So what are the settings that I need to choose on the OTDR? The first thing is the distance. So I don't know the distance on the trace. I need to, if I'm going into the field, into infrastructure which I don't know, perhaps for troubleshoot, I don't have the plans. If I'm installing, I know exactly what is my length. I need to choose a distance. So how do you do? How do I do? I just go and try to change it until I see the end of the fiber, where the fiber cuts. Then the next step is the pulse. So what pulse is the better one? Should I use a short pulse or a long pulse? Is this the best resolution or low dynamic? So we know, and we went through that, is if we go for a short pulse, what's going to happen is I will be able to identify the events which are close together. If I'm going to go for a longer pulse, I have a lot of energy. And that's the same as you have on your, if you use your fibrillator, your high beams in the car, you're going to have your light going a lot of time. So that means you're going to be able to see longer, and you're also going to see the end of the fiber, and you do the characterization on the end of the fiber correctly. Just to give you an example, if you use a 20 microsecond pulse, which is here the top one, that means that if you have two events which are close to each other in 2 kilometers, you will see them as one single event. Okay, so it's 2 kilometer event which are going to be accumulated in one merged event. And the time. So how long do I want to do my acquisition and my average? And then apart from these three combinations, which we have three combinations, is if we have 10 engineers going into the field, how do we make sure that all the 10 engineers will come back with the same settings on their traces, on their OTDR? So this is how the OTDR is been set up, and I use the OTDR, but there is another ways of using the OTDR helped by the software, like it is the case of IOLM, to face these challenges. Just for you to have a revision of how the splitter ratios work, I have here a small table which explains, for example, for a splitter 1/2, we have a loss of 4.4 to 5 dB. 1/4, it's 7 to 8 dB. 1/8, 10 to 11. And this is the splitter loss, typical splitter loss that you will find on FTTH PON. So let's see how we can measure this FTTH network using different pulses. So let's start with the short pulse, drop fiber characterization. So the short pulse will be able to identify the small events which coming just on the bottom. But what can I see here after the 4 and 5? So I don't have any information at all here. So as soon as I have the medium pulse, I'm already able to see more than I could see earlier on, and I see already a longer link, which I was not expecting to see. So most of you and the people that could not, so that have experience on the OTDR would always increase to the maximum power to see when is my link ending, and then they will recognize and do a reverse or backwards OTDR measurement. So, and then we have the long pulse, accurate end-to-end loss. So this is what is going to allow me to do the end-to-end as well, the fiber characterization, my dB per kilometer attenuation specifically for the end of the fiber. But no resolution here on the events as we had, for example, with the medium pulse. So how do we make everyone work on the same way, and how do we make everyone bringing all the results, all the same results back? So, and the reason for this is IOLM. So IOLM stands for Intelligent Optical Link Mapper. IOLM, brought for EXFO, is property from EXFO, requires minimal user setup required. You just need to go to the field, select the wavelengths, launch the cable length, and test configs. So, and how it does, it just uses the OTDR, so it uses the same engine, runs on the same OTDR that you already have. And then it just characterizes the link using multi-pulse acquisition. So it does all the job that we need to do, but it does it 6 to 7 times quicker than a manual operator or even me doing the OTDR would do. How does it show the results? It shows the results in human language, let's say, where you have all the elements identified. You have the global results, the whole link distance. In this case, you have the link summary. It tells you the loss, a link URL. And then it gives you the event location and loss details. Here we can see clearly that I only use one wavelength, so I'm using only 1550. And because I had a fail, and now I click on my element here, I have the diagnostics and user help, which is something as well that the OTDR will not give you. We even the OTDR and our OTDR gives you the tables, which you have the elements and you have potentially thresholds, pass fail. If you try to do the same measurement with different pulses with the OTDR and you compare them, you will see how difficult it is to achieve the conclusions when you have only one pulse. So, and with the IOLM, we avoid that because we use all the time the same multi-pulses. So we have always, all the time, repeatability of the measurements. And the guidance here will tell you, make sure the fiber is properly spliced. For example, the loss could be due to a low reflectance APC, and even points for the possible macroband, which tells and advises the operator to try to test with 2 wavelengths to confirm the macroband, inspect the fiber in the area to find excessive bending. So it's the principle of not leaving faults behind that the IOLM tries to emphasize and try to fix it for the operators and for the technicians in the field. So IOLM is based on link-aware technology. As I said, is intelligent optical link mapper and is unique EXFO OTDR application. So what are the other equipments that we talk about in the beginning for our FTTH and our point-to-point troubleshooting in our installation? Here we have our the optical fiber multimeter, OFM, and here we have, it's just a category.
Nuno, I just interrupt you a second. But thank you for the presentation so far. Jeg vil bare lige høre, om der er nogen, der har nogle spørgsmål til selve OTDR-delen. Men for lige at summe op, så det som EXFO kan, når vi kommer til OTDR-test, det er jo det her Intelligent Optical Link Mapper, altså IOLM. Og som I kunne se, som Nuno han sagde, altså ved bare at trykke start og ellers bare meget få oplysninger, man skal give OTDR'en, så får man en fuldstændig first time right test af sit link, vist i pædagogiske Lego-klodser i rød og grøn, alt efter om det er pass eller fail. Og så snakker alle teknikere sådan set samme sprog, uanset om de har testet med OTDR og IOLM i 20 år, eller om de er nye og har testet i en uge, så snakker man samme sprog, fordi det er den samme automatik, der ligger bag testen på de her x antal pulser, som den udfører i samme test. I modsætning til, og jeg ved, der er mange garvede fiberteknikere derude, der godt kan lide den gode gamle OTDR, men der skal man jo først og fremmest kende sit link lidt, hvor langt er det, hvad for en puls vil man gerne teste på, og hvor længe vil man gerne teste på hver bølgelængde osv. Og hvis man skal analysere et helt link på den måde, så kan det godt komme til at tage faktisk en del længere tid. Og er det den nye tekniker derude, frem for den garvede, så kan man komme hjem med nogle vidt forskellige resultater. Det tror jeg, I alle sammen kender til. Men er der nogen, der har nogle spørgsmål inden nu, når han går videre?
Godt. Kan man bruge det her IOLM til så måle på en live fiber? Kan man få sådan noget?
Godt spørgsmål, Thomas. Tak for det. Det kan du sagtens, og nu var lidt inde på det i starten, hvor han havde en slide, der viste sådan en hel by, skulle jeg til at sige, en hel infrastruktur. Så det vil sige, hvis der bliver transmitteret på 13, 10, 1490 eller 1550 for den sags skyld. Hvis man har en live bølgelængde på sin OTDR, der hedder 1625 for eksempel, eller 1650 nanometer, så kan du filtrere trafikken fra, og dermed skyde med OTDR'en på 1650, som er en bølgelængde, der er ledig, og dermed fejlfinde på 1650 i stedet for. Var det svar på de spørgsmål, Thomas?
Ja, tak.
Super godt. Alright, Nuno. Thank you, and then you can proceed with the Optical Explorer.
Okay, so the Optical Explorer is the new proposal from Expo, and we will see how what is the advantage of an Optical Explorer and what is the difference as well, and how can it be useful and how can it fit the industry at this point in time. So our industry is definitely transforming and asking more from our networks. So it's massive fiber rollouts needed, network densification for the 5G rollout. As I told you, Corning points for 100 times more fiber than the 4G. Quality control, making sure that we are always on time, and then checking that our factories are operating, and the need of always from us to be always connected to the external world. Inclusive having Netflix on our mobiles, and I have here just a few cases, and this was from this week, which sadly we are always working from home, but UK mobile networks went down last week, so Cisco WebEx video calling service using a record usage. So this was from March 17, and can they even some here the New York Times just asking, well, can the internet handle it? And for sure, with this stress on the network, even Netflix moving scrolling down for 144 the definition from the video, from normally what we have, the Full HD or the HD. It's always interesting to see that even with the good infrastructure that we have, we still don't have what is enough for us as a community or as a city to live for. So and the OX1 is actually something that can help with this. Why? Because with the quality and control, we have the challenge to get full visibility of infrastructure and robustness, keep control over quality of service all the time, demanding versus capacity, reduce the cost, but always speed up the deployments to meet these demands of data and shortage of expertise. So making sure that everyone that is installing is capable of operating the fields. For example, the equipment. So for example, an OTDR, and this is the example. In order for you to be, or for us to be proficient with the OTDR, we need time. We need, I would say, weeks of experience. We need to know very well our network. So IOLM and OX1 make it much more easier to troubleshoot the network, because the expertise is embedded on the algorithm behind the tester. We need as well, if you want to maximize and if you want to go and look and increase our network efficiency, we need to as well to have low test gear, which we can have more test gear. And you, of course, you cut on maintenance of optical tools like calibration, which is sometimes is a problem for the operators when they have 1,000, 2,000 equipments and they want to send for calibration, not only because of the money of the calibration, because also they lose the equipment for 1 or 2 weeks over a year. So that means that equipment will not generate revenue. And reduce as well the heavy test procedures. So we are living in a technology era, and reducing 67 method of procedures or just test specs, it's always welcome, which will avoid human errors and truck rolls and deployment and repair delays. So where does the OX1 sit into it in terms of money and measurement capability? So here it is. So the OX1 is not an OTDR. So it's something that allows you to do a fast validation of the link. It's really, really quick. It can give you the results in 3 seconds. So imagine that you're testing a cable, and the new ribbon cables and the other cables that we're going to see in the market with thousands of fibers. 3 seconds per fiber is much quicker than 20 seconds OTDR or other. So there is some as well a different aspect here, which is not a characterization tool. So it's not a tool who's going to give you a curve or a trace, but it's a tool that was going to tell you if your link is good or bad, and is going to sit above the light source and power meters. Why? Because it's a multimeter, and if you compare with the electric multimeter where you have amps from current, volts, we have resistance, ohms. Here the OX1 will give you not dBs. It will give you dBm for the loss. Is going to give you dB for the loss, dBm for the power, and the kilometers of the fiber. So you will be able to pinpoint for a fault finding in long lengths. And because you have, so of course it's going to be cheaper than the OTDR, you will be able to empower your technicians in the field. So let's see what are the functionalities of this equipment, the Optical Explorer or OX1. So first of all, the range is up to 40 kilometers. So you can use this for PON, last mile, or for point-to-point networks, which is even for metro data centers, and you are able to go and you're gonna be able to go up to 40 kilometers to have the distance and the ORL and the loss. I'll just show you in a better example. So this is only a few cases where you can use this equipment: drop cable, CO, FTTH, point-to-point, deeper fiber dip. For example, if some of you are installing 5G rollouts to the antenna, it's normally is not a huge link, but with this equipment, 3 seconds at least you have a validation of the link, good or bad, and the report. So let's see. And again, first time right, no blind spots. That's what is behind our equipment with these software assistance tools. What are the modes of operation of this equipment? First of all, we have our test, which takes 3 seconds to check the fiber health, which is called the Flash Advisor. So Flash Advisor, this is something that EXO brought it in the market, which gives you just a rating from 1 star and 5 stars. And here the question is, what good looks like? Again, I have 5.8 kilometers of fiber. I have a loss of 3.7 dBs. I have 38.3 ORL. Is this good or bad? So imagine that you are working with a team of 5 technicians or 5 engineers, field engineers that go, and they bring you these values. How do you know if they understand if the values are good or bad? So that's why Expo brought into the market the Flash Advisor. You can have the traditional pass or fail based on your thresholds. That's also available. But the Flash Advisor will give you a comparison between the links, which is a correlation between length, loss, and RL, all in 3 seconds. So the second mode, so we have not only the troubleshooting modes, but we have as well the light source and the power checker. So if you have no power loss at the customer facilities, here looking into the FTTH PON, you just need to simply plug the fiber here, and you will have your loss. And you can also use the light source if you want to investigate what's happening on the other side, or for example, if you have a live fiber detector, so you can just inject the tone and pick up on the other side, especially for data centers or buildings where you want to install the fiber inside. So let's imagine this case where you go to the customer house and you have a fault. So you go with the power meter and you have power loss. The ONT is above the threshold. Let's say the threshold is neg 29. You have neg 35 power loss. So what are you going to do? What do you do nowadays? Nowadays you investigate. Perhaps you're going to use a VFL, or you're going to call someone with the OTDR, or we're going to pick up your OTDR. So with the OX1, you don't need an OTDR to find the fault. So you can find the fault yourself after measuring the power with the OX1. And the way it's going to tell you is going to point you that at 5.8 kilometers, you have something which is a connector in this case, which is a faulty one, which needs to be repaired. So it's not going to look into the whole link, it's just going to look into the link and identify the element which is causing your problem, which is causing the fail or a lower rate on the Flash Advisor. So if you want to go further down, and here we had our Flash Advisor, Fault Explorer, and now we have our link mapper. If you want to go and detect the rest of the faults, now you can use the link mapper. So this one will not going to be 3 seconds or 5 seconds. This will be longer, but it will spend more time to unmerge the events that we may have in the field and to characterize the elements that we have in the field, so that you can check each one of these elements. It's very useful, for example, if you want to change or to replace a patch cord or a lead inside of a section of your network, and you actually want to find where is my next connector and how long is the fiber I need to replace. So this will make your work completely quicker and massive difference on the way you work without the need of having an OTDR if you don't have, or an ILM. So just to run it through a few of the views that we have here, because it's a very practical device and very simple to use and requires minimum training. And as part of the Expo experience, especially in Canada, we just had some teams trying it out, and I strongly advise you for checking on our channel on YouTube, where we have some videos about some technicians and field engineers trying them out. We have here the first mode, which is the Flash Advisor, where we have our readings in detail, so the loss and the RL and the distance. So if you want to go for the Fault Explorer because we found the problem, this is what you're going to have in detail. So again, we have the same identifiers here, but then we start seeing into the connectors. If you just tap into the connector, you will going to be able to see it. There is, because of the versions of these OX1, we have the version with 1310, 1550, and 1650. If you get the installation one, which is the 1310, 1550, or the combined one, which is the 3 wavelength in one single unit, you are as well able to identify elements like connectors, splices, and macro bands. That's why as soon as you have 2 more wavelengths, you're going to be able to identify macro bands as well. And as you see here, you have your link mapper. Um, so in terms of patents and what did we bring as well to the market with this OX1, essentially we have a lifetime calibration, so which makes sure that your OPEX gets reduced to the maximum. So the cost of ownership, being you an operator or being you a contractor or an engineer, so you're not going to have the need of sending this for calibration, like so you're going to keep yourself with the equipment for longer without the need of sending for us to repair or to staying a few weeks down like happens on the OTDR. It has as well a click-out connector. So it's the first unit in the market, and this is a patent now for us where you can remove the connector. So no more damaged connectors. You need 2 weeks down. Needs to be sent to the factory to replace the connector. So you can replace it on yourself. We have even inclusive a mode which allows you to test the connector before sending or rejecting it. So we don't want you to replace the connectors without the need of doing so. So it measures the reflectance on the connector and the loss and tells you if the connector is good or bad. And you can replace the battery if you require in the future time. In terms of the way the result is presented, so you finish the job. You don't need to do homework. You can simply connect your device, which is a standalone device, OX1, to an application on your mobile, which is free. Just go to the Optical Explorer. You pair with the device through Bluetooth. So you just and then you are able to connect and check the results. So here we have different results. Or if you are working a job, for example, a job with we have here a job with 7 fibers. So we will have one report with 7 fibers attached to it. So this is the kind of functionalities that we're trying to bring as well into the market with this unit. Not only make it quick, make it simple, but also providing some results, some proof that the job is done. It's inside of the what we intend for the network, what the operator requests me to do. And that you have a proof run done on time, which you can generate from your mobile and you can send by email with no homework to do afterwards. So we have now the PX1. I don't know, Jakob, if you want to add something on OX1.
Yes, I will. Thanks. Bare lige for igen at summe op på det, som nogen har været igennem med Optical Explorer. Som sagt, så er det Exos allernyeste produkt, og det som vi ser i øjeblikket, det er, at der er rigtig mange, der er interesseret i det. Det kunne godt, jeg tror det er allerede Exos nye flagskib sammen med IOLM, OTDR-applikationen. Men det man kan med den her lille håndholdte tester, som ikke, den fylder ikke meget mere end en håndfuld, det er først og fremmest, at man har en powerchecker, et parameter, så man lynhurtigt kan se, har jeg det lys, jeg skal bruge, både i dBm, altså en powermåling. Har man en lyskilt i den anden ende, som man gerne vil lave en reference til, kan man lave en loss test, altså for at vide, hvor mange dB taber jeg fra den ene ende til den anden. Man kan detektere tone, så har man puttet tone på det her, den her fiber, så kan man detektere det med Optical Explorer også. Man har muligheden for at bruge lyskilden, laseren i enheden, til at sætte tone på et kabel, til at sætte lys på et kabel, hvis man har et parameter den anden ende, til at lave en dæmningstest. Og så selvfølgelig det allervigtigste, alle de her ting med hurtig fejlfinding, 5-star rating, det vil sige rimelig hurtigt finde ud af, er den her fiber god eller dårlig. Har den 1 eller 2 stjerner, så skal man sandsynligvis ud og rette nogle fejl, så kan man fejlfinde dybere. Har man 4-5 stjerner, så giver det alle teknikere en ret god idé om, at fiberen den har det godt. Og de her 3 forskellige testmuligheder, hvor man får mere og mere info, mest på den komplette linkmapper selvfølgelig. Man kan skifte connectoren ud i marken, så man skal ikke sende enheden til reparation. Man kan købe click-out connector, som have som reserve, så kaste den beskidte eller ødelagte connector over skulderen, og så placere en ny en i. Og det behøver man ikke at kalibrere den for. Livstidskalibrering, omkring, jeg tror i databladet står der, at det er 10 års kalibreringsinterval, så der er lidt tid at løbe på. Jeg har demoenheder, når de ikke er ude. De er ret eftertragtet. Så kontakt mig, hvis I har lyst til at prøve enheden. Så skal vi nok finde ud af det. Og som sagt, rapportering via mobilenheden, det er din mobiltelefon, Android og iOS. Man har den altid i lommen, telefonen alligevel, så det er nemt at dele den vej igennem. Nogle spørgsmål til Optical Explorer?
Spørgsmål?
Ja tak, Jesper.
Det her datasæt, der definerer, om du har 1-5 stjerner, er det et fast datasæt, eller er det et datasæt, man selv kan gå ind og definere?
Godt spørgsmål. Det som den testtype hed med de her 5 star, det er det, der hedder Flash Advisor. Hvor Expo har fortalt den her, hvad kan man forvente sig af en strækning, der er så lang med det her tab og den her OL-værdi. Du kan godt selv gå ind og sætte thresholds, og så er det selvfølgelig det, man pass-failer i henhold til. Var det svar på spørgsmålet?
Tak.
Ja, super. Andre inputs? Super. Nuno, you are allowed to go on. Thanks.
Okay, thank you. So we talk about the PX1, Power Expert 1, and we will go again into the PON system troubleshooting, and this is as well to show you what are the challenges I referred a little bit earlier on in this specific case of using just a power meter. So the optical power expert one is our newest power meter. It's a power meter which is very compact, very small. I have it here one. I will show you how it looks like, how it feels like to have it in the hand. So just you could see how small it is and how compact, and as well really nice LCD bright we can use outside and in dark places as well. But what are the challenges of using a power meter when we're troubleshooting a PON network? And with all these flavors of PONs that we have, being GPON, XGS PON, Ethernet PON, different wavelengths, it's to make sure that the people that go to the field know exactly what they are looking for in terms of filtering and in terms of wavelengths, central wavelengths for measurement. So if we go to the customer house and we have this no power at customer house problem. So what is the wavelength that I'm going to use for a PON? I know my downstream is at 1490, so I will pick up perhaps 1490 nanometers and I will measure here. But what if I have video or like we had on the coax cable, the TV signal being transmitted on the coax at different wavelengths, as we may have it on the fiber as well. So it's important for the field engineer to know exactly what he's measuring. So even if he's measuring neg 14.23, what is the value that he's receiving on the OLT? That's another problem, because neg 14.23, it may be good or bad. But you cannot say if it's good or bad if you don't know exactly what is your central office OLT transmitting. So now, if I know my central office is transmitting at 4.23, I know I can see that my loss would be the difference between them. But is there an easy way of doing this as well? So and the question is, can I use a power meter for FTTH PON? Yes, you can use, but you need to be very oriented, and you need to know exactly what you need to measure and which situations is going to work. So the other way of doing this is to use a proper PON power meter. So the PON power meter is just a device where you have it's a power meter on his concept, but here what you have is a fiber that comes from OLT that plugs here, and then a fiber that goes to NT, which is intercepted, that lives here and then goes to the ONT. What is the case scenario here? First of all, it will allow the ONT to transmit at 1310. Because if you disconnect the fiber from the OLT, from the ONT to measure with the normal power meter, you would not have the 1310 signal going upwards. So that's why it's very important to have something like this if you want to measure upstream and downstream. The other thing that we have with the PON power meter is, as you see here, you have the GPON value and you have as well the XGS PON value and the RF video, which is a 1550 video, 5050 nanometers signal in one go. So if you are an operator, if you are a contractor, you have people working for you that go to the field and they don't know what, they're not sure what they're going to measure with something like a PON power meter 350D. They will be able to measure everything, and you are sure that they are measuring always the right value all the time. So it's consistency and as well accuracy in terms of measurement. So now I have a small demo prepared just in terms of ILM. No, it's just gonna close this. Okay, so okay, so what you see here is actually my test setup. So I have my ILM OTDR. In this case, I'm not going to be using, this is a Max 730C. I will use an FTB1 Pro with a 720C module, and I will be connected to a two splitter. In this case, is a dual configuration splitter, 1x8 plus 1x8. I will show you here on the screen. So this is my platform. So where I have, in this case, because it's an FTB one, I'm using an FTB 720C, which is an OTDR in this case for multi-mode and single mode. I will open my application, and as I said earlier on, to have ILM, the ILM runs on the OTDR engine. So in this case, I have both options available. With ILM option, I have always the OTDR option available, especially if I have the ILM advanced. So let's review what we did earlier on, and I will start my OTDR. And we will go. So as soon as I have a starting measurement on the OTDR, I can see here that I have the range, and with 5 nanoseconds, I almost can see nothing, only noise. So I need to start increasing the pulse if I want to see something. And this is one of the chances that we spoke earlier on. So if you go 100, we can see a bit. I can see, if I have trained eyes, I can see already here one splitter, and then I can see perhaps here another one, but I don't have enough power for it. So I need to go a little bit higher. So I can see already another definition on this side of the curve, but I need to increase my range if I want to go further down. And what do I have here? So for those of you that work with the OTDR, you will recognize this as a UPC connector due to the reflectance, and that's why you may have on your network UPC or APC. The UPC, because it's a flat cut on the connector, you would have always these high reflectance peaks, which is not seen on the green APC connectors. So if you go above, you can start seeing now the end of the fiber. So different pulses, different settings will give you always different measurements. So if I would characterize these two splitter configuration with the OTDR, I would need to do for sure different measurements and stitch them together in order to have a good, correct measurement. So what can I do? What is the solution for this? As we've seen, ILM. So ILM allows me, so ILM will take me, I'm doing here only 1550 nanometers, one wavelength, but ILM will give me exactly the tools that I need for the correct characterization of the link. It's going to run for 1550 nanometers. I have already here at 1550 nanometers for 1.5 minutes. I have here already my launch fiber, which is calibrated towards this wizard here. So the only thing that the technician or field engineer needs to do in the field is just to select launch fiber, press calibrated, disconnect the launch fiber from the test from the TUT, the device under test, or the fiber link, and the IOLM is also the only application which will give you the right launch fiber automatically. If you have any questions about what is the best launch fiber, can I reduce my launch fiber? You have as well a wizard box here which can give you some tips on what is the best launch fiber that you may have to choose. So once it's done, we have here our element view, as we have here as well our file elements. We can see even for someone that is not trained on OTDR can already see elements here, which is meaningful. So everyone can understand that where the splitter is, what is the distance between my A beginning of the link and B end of the link to the splitters. If they are inside the values that we say they should be, which is the test configuration. What is the loss on this one? Why is this element failing? So you have here again possible macroband. Try to test with 2 wavelengths to confirm the macroband. That is why it's always a good practice to test with 2 wavelengths. So further down we have as well 1 dB loss at 1550. So potentially perhaps a macroband here or a very bad splice. And we have here our element view. So if you want to have a different view. So, and with IOLM, if you have customers asking for the OTDR, yes, IOLM gives you the OTDR trace. So you are able to get the IOLM trace if you want from OTDR trace from an IOLM result. And what is so if your customers specify, I want always an OTDR trace with a specific pulse width. Can I have it? Yes, you can. So you can define what is the pulse width that you want for the SOR trace and what is the acquisition time that you want, even using IOLM. So the way the system will work with IOLM Advanced option is that it's going to acquire these SOR pulse for after the IOLM measurement in order for you to have these results that you can give or deliver to your customers. Okay, so important for all on our products is always you have always this blue bar here on the right side, which allows you to give all the information about, and even if you flip, if you have a Max, an OLTX, 720C, or other instrument on Expo, even transport and Datacom, this is also familiar, which makes much easier to adapt to our platforms. In terms of naming and job naming, there is different functionalities, but some of these ones are just going to show you what can you do in order to optimize your job efficiency. If you put your cable ID and if you put your fiber ID, and if you have 24 fibers to test, you can always always use the increment fiber. So from fiber 1 to fiber 999 or fiber 24, like I said. So starting on fiber 1, and after this measurement till the next one, so it's gonna always show. Is always going to increase and increment the job, making your job acquisition faster. So this is just a few, one of the tricks that you can use in order to increment and also to avoid the post-processing, which is normally done when we have non-standard cable names or trace names on your units. So if I want to open, so if I have these results saved and I want to open a PDF, I can always close the application or minimize. And in this case, you're going to have for example, and this is what you may find as a report, a generated report in PDF of the link. So you would have your IOLM trace, you would have as well your SOR trace, and you would have your report table with elements as well, with some remarks that you may add here. So it's not mandatory you to have these. You can remove them on the user preferences, but it's just a complete report of what you can have. So in terms of IOLM, I will stop here. I was just going to show you a bit of so I'm just going to show you the PX1, which I just have it here. So I hope you're going to be able to see it. I don't know if you can see it. Perhaps, Jakob, you can confirm that you can see it.
Yeah, I can see it. And I'm just gonna turn into Danish for a second. Fordi vi snakkede lige om Optical Explorer før, der sagde, at det var Exfos nyeste produkt. Men PX1 er faktisk endnu nyere. Men det er ikke klar til at blive sendt ud til vores kunder endnu. Man kan godt lægge ordre, men det er lige på trapperne til, vi kan levere det. Og det er egentlig Exos nye parameter, som erstatter, måske er nogle af jer, der kender dem, FPM 300 og 600, som har nogle år på banen, som er nogle rigtige arbejdsheste, men nu har vi fået et sådan PX1 her, Optical Power Expert, som er lidt mere 2020-agtig og faceliftet. Og den vil nu lige vise her. Yeah, here we go, Nuno.
Yeah, it's just a small, I know we have a little bit of time, but it's just to see how small it is. So it's just a very compact device. As you see, basically my hand is as well similar to the EX1, which is one of our products as well, in terms of Ethernet testing and validation of speeds and protocol layers. So you have just adoption for, so you can just close this. So I was on the measurements. So you can have 11 calibrated wavelengths, as you can have 45 calibrated wavelengths on this unit. You can just have the reference dBm. You can have the reference in dBs if you want to do loss. So and then we have our settings, offset. So it's just very compact. You see very bright screen and if you're using gloves, especially in the winter, and you have always the option to save the results and just basically use the buttons here to save the results. So you don't need to use the touch screen. Here you have okay. So it's just a small overview of what we can do in terms of PX1.
And you know, how do you save? How do you report from the PX1?
Yeah, so it's the same. It's done on the same way as we do for the OX1, using the application on the mobile.
Perfect. Thanks.
So we try to, and the idea behind this is always to maximize. If you are working in the field, there is no need to do over processing at home. So if you finish your job, especially for the people who do night shifts, and I have some customers, I give always this example because it was actually something that I experienced. I had this engineer came to me and said, well, after finishing my job at 3 o'clock in the morning, I still need to go home, do the results and send it to my boss for him tomorrow morning to see. So and here the question is, if you have these tools, you can use it directly from the field. So that means you can drive home and just have peaceful rest instead of being worried with the results. So I think this terminates the first part. So I don't know if someone has any questions.
Det er i hvert fald nu, man har mulighed for at stille spørgsmål. til den første halvdel her. Eller ikke, vi er også over halvvejs, men inden vi går videre, lige at kigge en lille smule mere på Exfos software, der hedder Fast Reporter. Og jeg tror også, vi lige rører ved noget, der hedder Testflow, som er en applikation, der gør, at man kan gøre planlægning og dokumentation en lille smule nemmere i hverdagen, hvis der er nogen, der føler, at de har nogle udfordringer med det. Det tror jeg, at der er nogen, der kan genkende. Der er en, der spørger, om vi lige kan få 3 minutter til at fylde kaffe på, og det kan vi da godt aftale. Vi kan aftale, at kl. 10.30, der fortsætter vi. Men der er nogen, der lige har nogle spørgsmål her til første del. Godt. Okay, Nuno. Just a 3-minute break. So we're on again 10:30 Copenhagen time.
Yeah, okay.
All right. Thank you, Nuno.
Thank you.
Okay, jeg håber, at I har fået fyldt kaffekopperne op, eller taget et glas vand, så vi lige kan fortsætte den sidste halve times tid her. Og inden nu ligger på, I kan jo lige sidde og tænke lidt over, at vi snakker lidt om, at vi godt kunne tænke os, nu hvor der var så mange deltagere i dag, og med så kort varsel, måske at gentage en session igen i næste uge. Så hvis I lige kan sidde og tænke lidt over, hvad I kunne tænke jer, at det umiddelbart skulle handle om, så kan I melde ind til sidst eller på chatten, så skal vi prøve at se, om vi kan opfylde jeres ønsker. So are you ready, Nuno? Og Nuno, han er stadig ude at fylde sin kaffekop.
Hello?
Yeah, there you are. Are you ready for the next phase?
Yeah, yes, we go. So the next phase will be documentation. So it's going to be just a brief overview of the documentation, proposed documentation. And here I was just going to mention the 4 steps for successful optical deployments. So with no training, with no MOP, and here is a method of procedure or test spec, no best practice and no documentation, it's impossible to have a successful optical deployment. Being FTTH, metro, core, data center, you need always to have these 4 in order for you to be strong and to have a successful optical deployment. We're going to be based on Fast Reporter. So being Fast Reporter, where we can concatenate the traces, we can look into the OTDR traces, we can move, export from IOLM report or IOLM result and OTDR trace. And TestFlow it's a platform which comes with Fast Reporter, which allows you to connect all the testers and to collect the results from the cloud and to send. It's a cloud-based software architecture for you to deploy your network and to have the results concatenated and concentrated in one single space. So I'm just going to open my Fast Reporter, which I have already here open. So and as we see here, and Fast Reporter has been on the market for a long time. We just have Fast Reporter 3, which is the newest version. Very similar to, if we look into the way it's built, it's very similar to how we have Windows, Microsoft Office on our laptops, Word, Excel, and other softwares that we have. So we have the file, which gives you the main options. Then we have the OTDR tab, which has all the comments which are related with the OTDR. So if you are working with OTDR traces, you should only use this tab and the home one. If you go for the FIP results, so as you see here, everything is grayed out unless I open FIP result, which I can open. So if I open sample files, so the software comes as well with some sample files which we can just use for our training and for experiences purpose. So just open it. Open now, and now I have all the icons on IOLM which are not grayed out anymore, so I have options available. Then I have the FIP, Fiber Inspection Probe, so I can as well load a result to see how it looks like. So just single fiber connectors, just open something to see. And we can see exactly what we have on our Connector Max software on the laptop or on your mobile. But you can now use these ones to create exceptional report and to deliver and to archive the results. You have OLTS, which is ILM or optical test set. So you have optical power meter, chromatic dispersion, polarization mode dispersion, and have the cloud, and then we have our report, and with which you have as well the validator. So if you want to look into results and you want to validate them, having in mind the values here that we have on the table, we can run automation on validation results. So if you will have 1,000 fibers to analyze, you don't need to go through all of them. You can just run the validator option, which allows you to quickly, in a question of seconds, to understand if you have the right values, if you have good values, bad values, change values, events, wrong events, mismatch events, and all the analysis that you would like to do for the OTDR and for the other acquisitions as well. So let's start on ILM. So we have ILM bidirectional. We have, if you're going to go for the elements, you have here one element which gives you the loss. Then you have the second element, which is going to go. You can flip through the elements by tapping by moving the bar here to the right. As well, you can just simple tap on each one of these ones, and you're going to have the values. So I have here an example of, it's 96 fibers, I think, and they are all done at 1550. So for this case, this is an example of someone is 120 fibers, beg your pardon, and this is just a case of someone that is installing, is testing a fiber cable drum of 120 fibers. It's just a cable before the installation and after the installation, and so this is the results before the installation. And they have almost 1.4 kilometers of fiber, and they have all of these results. But because they did the test and they didn't have all the information, they didn't fill important information for their customer, for example, the job ID. So with Fast Reporter, you can optimize, so you don't need to go and edit all the files. You can just select all of them, tap on job ID, and we can put here Denmark case. So it's just case. We can just do edit, and now all the files are now edited with the same identifiers. So this allows me to be quick, efficient, and simplify the job that I could do for post processing. So I can change my operator. So I can put Nuno. So it's just a question of batch work and speed up the process. So ID the cable or cable ID. So you can change. Perhaps I don't want ID the cable. I want cable ID, fiber ID. So I can basically change and match the files. The same thing for other information. For example, here for the ILM, I can also do the same kind of things. Apart from this simple modification, if I want to go for the bidirectional, if some of you do as well bidirectional, I can open as well an OTDR example of a bidirectional, which is normally interesting to see how quick. So I will open here an example with fiber 18, A to B, and I will replicate, and I will open a sample file for the OTDR as well, bidirectional B2A. So saying this, if you want to try Exfo Fast Reporter, you have 90 days free trial. And you can just, with the email, subscribe and have these for 90 days where you can try and you play with the traces, your ones, and as well the sample files. So as you see, this is a traditional bidirectional view. So we can have display virtual bidirectional or don't display. So you can, if you remove, we don't see them. If you have, we see the blue trace, which is the bidirectional, as we have as well. If we go for the event table, we have as well the average. So not only 1310, 1550 values like we have here, so A to B and B to A, we will start having the average. And the average is important, and that's always the best practice says to do the bidirectional. Because the bidirectional, if you have a gain, and if you have if you do the gain from A to B, if you do B to A, you will have a loss. Physically, you cannot have gains. So the bidirectional will always have the real value for the loss for the fiber. And especially this is really important as well, because in the field, as we've seen for the OTDR, you have different fibers being spliced in the field. And because of the mode field diameters that you may have, These can be something that you will find quite often in the field, the gains or the apparent gains, I should better say. So if you have, and if your customer always require the PDF from the unit, and you have the ILM bidirectional, you can always you can go. You see here on the bottom you have different tabs. So you're just going to show you, but you can have as well the. So you can have the OTDR trace where you can just convert it to, yeah, so I just put that on the results. All right. So if I open now one of my folders here on the results, you will see that, okay, this one, folder. So it would be OTDR. Yeah, but this one we have. So you are able to generate the PDFs from the application. So I'm just going to open the ILM. So if new folder, just put that on the documents. Okay. So okay, so you are able to generate as it was on the application. And I should be able to do it as well with the OTDR. Stop. Okay. So I was not finding the file. Now I should be able to see it quickly. Okay, so this is the OTDR file generated from FastReporter as it was on the OTDR itself. And this is also flexibility because you can import from OLT from ILM to OTDR to SOR trace, and you can always generate as it was on the unit. So in this case, having FastReporter tree, it'll give you always the flexibility. If you forget to save the PDF on the unit, if you didn't save it, having FastReporter will always optimize this, and for your customer, it will be statement, PDF statement with the same, exactly with the same identifiers, exactly the same results on with the same pages. So another thing that we can do with our FastReporter is generating reports. So for example, if I want to optimize and I have all of these traces, which is 120 traces, how do I present this to my customer? Shall I give him 120 OTDR PDF results? And here is the question where we can optimize, and you can actually propose these kind of things as well. Make your life a little bit easier in the contractor side by optimizing and just doing, for example, here I will only select these 120 files, and I will use a template which I already have here. Yes, so I want to replace. And in a question of seconds, I have here a report with 14 pages where I have a full customization, which I can put pictures, I can put the name of my company, I can put any identifier that can make me as well do a little bit of customization, adaptation, advertisement for me as well, for my company. And I would have all of these parameters customized. So I have 120 results spread across different pages. Here it's just a PDF, so you would have different fibers. I can have as well in Excel. So if I close this, I can show you how quickly it is. So if I want to just move these, just double click, and I have the same bit in Excel. Okay, so have here, yeah, I can still do. If I want to edit, for example, some customers would like to have a new page. So they would like to have insert worksheet. Yeah. So they want to have a front page. So you can put anything, page. So it's 100% customizable, and we can represent or reproduce the same templates. So for example, if you have already templates that you normally deliver or they are requested by your customer, which have a specific format where you need to have the fibers on the right side and you have the pictures, you can use these templates. There is another templates as well, so I can show you how a template looks like and how it can be customized quickly. So if I open the default one which I'm using, so this is the one that I'm using. As you see here, these are the formulas that we use to just get the information. I can actually take these, I'll just come here, take this picture or this one, and I can just replace this one, save it, okay, and just close again, done it, and I can now generate the template. So it's the way the software is designed is in order to maximize your workforce, but as well to make it simple and efficient. So here you have simple 2 clicks, change the picture, and here you have. So we help you to set up the fast reporter and to customize the templates as per your needs as well. So this is just some of these ones. There are, with the software, there is already some templates that come with it. So for example, if I want a graph, I can always do OTDR and OTDR cable, or OTDR cable, okay. So you have these link results, and you can have as well, if you need the traces, or if you need the traces plus the FIP, you can do as well. For example, ILM summary. So there is plenty of templates that you can choose from. ILM fiber characterization, or ILM plus OTDR. So there is different combinations that you can do. So, and you can combine more than one result. So if your customer requires ILM plus FIP, fiber inspection probe results, you can also accommodate these ones into it. ILM. So I'm just going to try this one. Yes. Okay, so where you have all your ILM link result, you have your sections here on the bottom. And if you have 1000 fibers, this will be the easiest way to have only one PDF with 1000 results. An efficient way. You finish the job, you just need to save and send this one with the information. It doesn't need to be, as I said, it doesn't need to have all these fields here. You can simply delete it on the template, and then for the future generations, it will only show which fields do you want to have. All these fields come from these information that is provided from the file and that you inserted on your test equipment, being the summary, identifications. So here we have the unit model, you have calibration date, So all of that gets transposed into the equipment. So test date, unit model, as you see here, is going to be exactly what is being reported there. And this is just a small overview of the software. We don't have too much time, as I may understand, but in terms of fast reporter combinations, I have multiple customers that I'm working at the moment, and I can just show you some of the templates. So if you have any questions, I will leave you my email to Jakob as well, and we can discuss in more detail. If you would like me to give you a draft of what we can do, I think that is always a good way of starting. In order to make perhaps some small adjustments, sometimes you need to submit that to your customers or to your operators, just for them to be convinced or to be aware that there's going to be some changes or that they are happy with it, and then you can maximize your efforts on what really matters on the test. So here we have for the bidirectional, just another example where we have bidirectional results, but not only the bidirectional, we have bidirectional from A to B at 1310, then we have unidirectional A to B, B to A, and then we have another bidirectional for the 1550 with again A to B, B to A. And nothing actually stops you from adding more pages or other pages into the template. So it's a free customizable template that we provide. In terms of test flow is the other platform which comes with the license on Fast Reporter or with the trial period, and this allows you to you can always have it on the unit that you are working with. So as you see here, test flow, and just in very brief terms. It's what allows you to, so you will tell me that I'm online as a user, and it's just syncing my jobs into the unit. So when I go to the field, I don't need to take paperwork or test specs with me or test configuration, network configuration. If I have already someone loading that in the office, or if I load them in the office, I know exactly where do I need to test, which fibers have been tested, which ones do I need to test, and then when I have all the results, I just connect my unit back in the end of the week or in the end of the day. I just connect my units back into service, and I will have the jobs being synced again. So I can add, for example, a new job. I have here one. So just for you to have a view. So I have. And the way how it works is if I have test flow, I can always click on here on the bottom, and he would just open the platform that I have. I need to close this, of course. And it's simple as all the ID, all the fiber ID already comes defined by the server, which is a cloud server software, so I don't need to be typing fiber names or other other specifications. This was just a small overview, so it's not the case. So I strongly suggest you, if you have some queries about Fast Reporter and the way we can generate a template, for you to come back to me. So you have here my email. I have as well Jakob's information. And we can grab a template that you already have, do some trials again, and I send you the customized template that can optimize, do the automation of 100% of the post-processing job that you do to analyze the traces. So I welcome any questions that you may have in regards to this part of the documentation. So I don't know if Jakob, you want to add something else?
Yes, thank you, Nuno. Så er der nogen, der har nogle spørgsmål direkte til Nuno lige omkring det, han viste her. Så er det næsten nu her, man skal skyde. Men ellers så, det som Nuno gennemgik, det var selvfølgelig fast reporter. Måske ikke en lige så spændende demonstration i form af billeder og så videre, men vi har kunder, også nogle af jer, der er med her, som bruger fast reporter utrolig meget. Også til tovejs, altså bidirektionelle analyser og så videre. Der er nogen, der slet ikke bruger fast reporter. Og som Nuno sagde, så er det jo også muligt på jeres Exo-platform i marken at lave PDF-rapporter derude. Men skal man analysere mange filer, skal man lave en PDF-rapport inkluderet med mange forskellige testresultater, så er man nødt til at gå fast reporter-vejen. Og har I brug for det? Har I brug for nogle templates til rapporter og så videre? Så som Nuno sagde, så tager I enten bare fat i mig eller direkte i Nuno. Testflow-delen, vi har næsten lige holdt et seminar omkring det, og jeg har haft en Danmarks tur, som er rimelig omfattende. Der er også nogle her, som jeg ikke har haft besøgt, men har I interesse i testflow, så lad mig vide det. Vi har en del kunder allerede, der bruger det. Nu var Nunos online demo, den fejlede godt nok lige, men hele princippet i det er, at en projektleder eller en formand, eller for den sags skyld en tekniker, sidder og definerer alle jobs på forhånd, hvad for en testkonfiguration, hvad skal filerne hedde osv. Det bliver sendt direkte ud til teknikeren i marken, som går online med sin tester eller sin telefon, hvad man nu skal. Trykker på den her lille cirkel, den åbner automatisk den test, man skal udføre. Og lige så snart testen er udført med det rigtige navn, som er givet på forhånd i forhold til parsfælder i forhold til det rigtige konfiguration, så ryger testen direkte op i skyen, og man kan gå videre til næste job. Og inde på kontoret, eller hvor man nu skal sidde og rapportere, kan man se, den er udført med en eller anden kommentar måske, et billede osv., og man kan sende det videre til kunderne, når tiden er. Så det hele ligger i skyen, som jo er ret op i tiden, må man sige. Alting skal helst foregå deroppe. Så der er ikke, smider man en USB-nøgle væk, så er det ligegyldigt, fordi at det hele er sendt via nettet op i skyen. Og jeg kommer meget gerne forbi, som sagt, og viser det her. Alle Exfos platform, som vi har vist i dag, det lille parameter, som kommer lige om lidt, OX1'eren, fiberinspektionsgruppe, platformen med OTDR og IOLM, alle de her platforme fungerer med testflow, så man er ret godt dækket ind. Og man kan også have billeddokumentation. Godt, så fik jeg lige vendt den, og så kan jeg også se, at vi faktisk overholder tidsplanen, som var sat til kl. 11. Men er der nogen af jer her, der er tilbage? Der var nogen, der lige hoppede af fast reporter-delen, det er også fair nok. Er der nogen, der har nogle spørgsmål til enten mig eller Nuno?
Spørgsmål?
Yes, sådan.
Hvad er kostprisen i forhold til det gamle parameter til det nye?
Det er det samme. Så,
okay, fordi vi har lige bestilt de gamle nemlig.
Ja, korrekt. Og det, jeg kunne fornemme, det var fordi, hvis vi lige skal tage den her, vi skulle bruge dem med det samme. Som sagt, så kan vi ikke levere den nye parameter endnu. Det er lidt ude i fremtiden. Men ellers så lad os lige tage den så.
Ja, lad os gøre det.
Ja.
Tak.
Jeg kan se, der er tjekket et spørgsmål her, ind her. Is there any option for spectrum view of CVDM and DWDM channels on any of the... nu står der meters, men jeg formoder, nu kan jeg ikke lige se, om der har stillet spørgsmålet. Er det i forhold til at måle powerniveau på de forskellige bølgelængder, eller er det en decideret IOLM OTDR-test på VDM? Er der en, der lige kan uddybe det spørgsmål? Power. So, Nuno, can you see the chat? Nuno?
Hello?
Hello. Can you see the question in the chat? Or is it only me?
Spectrum view.
So do we have, and I know we have, any equipment measuring the power on CWDM or DWDM?
Yeah, we have. Yeah, I'm just gonna show you this.
Exactly.
So besides going into the because we have even the PX1 is going to be able to do 45 wavelengths. The PX1 Pro, 45 calibrated wavelengths. So some of the channels will be there, but we have as well some products like the optical wave expirer, which is going to give you the power per channels if you are analyzing the whole fiber at one go, which is a very sensitive but very intelligent way of reporting the power levels on the grid, on the ITUT grid. So this is one of the products that we have on our portfolio that can do that on a visual, presentable way, as well intuitive way. And if it's on a small platform, which is the Max Tester, all the wavelengths, all the channels in one single acquisition.
Perfect, thanks. Så det er det nyeste produkt, som Nuno viser her. Vi har også decideret CVDM og DVDM parameter, hvor man går ind og kigger på specifikke bølgelængder også. Jeg håber, det gav svar på spørgsmålet. Vi sælger også CVDM OTDR med IOLM View, så det vil sige, at man får vist, hvor der er mukse og så videre med de her IOLM Lego-klodser, som gør det meget nemmere at analysere på sådan nogle VDM traces. Tak for det spørgsmål. Andre, der lige har noget på faldrebet her? Nope. Jamen, så vil jeg først lige... Nuno, do you want to say something before I end the session?
It's if you want to take my email, yeah, I'm sure they can give you. You can get it from you, Jakob. So, and it was a pleasure to be here with you. So, any questions that you may have, please don't hesitate in contacting me or the whole team from Expo. So, thank you, everyone.
Perfect. Thank you, Nuno. Og så vil jeg selvfølgelig også afslutte. Det var faktisk dejligt at se så mange, der havde mulighed for at deltage med så kort varsel. I de her coronatider er der nogen, der enten sidder derhjemme eller har lidt ekstra tid til at i dag forhåbentlig lære noget nyt, eller for at genopfriske noget viden. I er meget velkommen til at tage fat i mig efterfølgende. I kan finde mig, svare på den mail, I får sendt ud selvfølgelig med nyheden her, eller på LinkedIn, hvor jeg også prøver at være aktiv, så der kan I også kontakte mig. Og ellers så snakkes vi bare ved. Der var ikke nogen, der meldte ind omkring, hvad I kunne tænke at høre om i næste uge. Det kan være, at Nuno og jeg selv brainstormer, og så I måske får en invitation i jeres indbakke eller via LinkedIn. Og så er I selvfølgelig velkommen til at hoppe på. Men tusind tak for i dag. Jeg håber, I fik noget ud af det. Og så må I stay healthy i de her tider, om I er i Danmark. Jeg kan også se svejerne med fra Island, eller hvor I befinder jer i verden. Så håber jeg, at I fortsætter med at være raske. Vi snakkes ved. Mange tak for i dag, folkens. Hej hej.